All right, we're still working on operations with monomials. The last video was adding and subtracting them. And you know, when you add and subtract like terms, you do not change the exponent because of the ladder, the exponent ladder. Well, this quick lesson is on what to do when you are multiplying monomials. And I talked about that a little bit when I showed you the exponent pyramid or the exponent ladder. Some people call it the pyramid. Some people call it the ladder. You can call it whichever one you want. Okay, but on page 2, we're talking about multiplying monomials. And I wish I could figure out what to do about this annoying shadow. All right, but I can't do much about it. All right, but let's see. Multiplying monomials. When you multiply, you add, I was eating pasta salad earlier, and I got a little bit messy there. A plus B. When you're multiplying, you add the exponents. Now, do you need to memorize this rule? No, because if you know the ladder, that's all you need. When you multiply, you add the exponents. Remember, exponents are always one below. Okay. So, for example, number 17, x2, x3, when you multiply exponents, I might draw the ladder right here, you know, with symbols. Let's see. So you have add and subtract, multiply and divide, and then powers and roots. It's going to be a while before we get to that. But here, when you multiply, what's below multiply, you add. So that's going to be x to the 5th. All right. Now, it's not 2x. Some people say 2x to the 5th, and that is incorrect. In front, you have a 1 and a 1. 1 times 1 is still 1, not 2. So that would be incorrect. Now, number 18, you do see a 1 there. When you multiply, you add the exponent. So that would be a to the 9 plus 1 is 10. All right, now let's move to some more complicated examples. Let's do 23, 24, 30, 33, 35, and 36. Those are the ones that we're going to do, and then we'll be done with multiplying. Now, again, when you multiply, the ladder rule only applies to the exponents, not to the coefficients, which are the numbers in front. Number 23, what is negative 3 times 4? That's negative 12. Now, you add the exponents separately on the A's, the B's, and the C's. Well, look at the A's. That's a 3. That's a 2. You add them together. That's a 5. Then you have a B, and that's a B1. You can't see the 1, but there's a 1. A B1 and a B5 is a B6. So you do the letters separately. You do the A's separately from the B's. Now, number 24, do not think that's subtraction. That's multiplication. Since it's multiplication, I'm going to go ahead and put parentheses around it because that's what multiplication is. Parentheses means multiply. Negative 7 times negative 4, those are called the coefficients. That's 28. Now, add the exponents on the P's. 9 plus 2 is 11. The Q's, that's 3 plus 6, that's 9. And the R's, that's a 1 and a 4, that's R to the 5th. And that's all you do. Number 30. All right, that's an 8 and a 10. Multiply the coefficients. That is 80. And then the C's, that's a 2 and a 3. That would be C to the 5. You add the exponents. That's a D1 and a D5, and that would be D6. Do you know what a D6 means outside of math class? A D6 also stands for a 6-sided die. That's called a D6. So if you play like, I don't know, Magic the Gathering or Dungeons and Dragons, they call those D6s. All right. Number 33. All right. Let's multiply. Let's put parentheses around this too. Now, 12 times 2/3. What's 12 times 2/3? Well, you can cancel 3 into 12. That's a 4. That would be 8. Now, if you don't know how to do that, you can always do that on a calculator. That's a Y1. Now, notice the X does not have an X over here. So there's nothing to add with that exponent. So that's just X to the 1. You don't need to write the 1. Now, the Y1 and the Y4, you can multiply those. That would be Y to the 5th. All right. Now, number 35, what do you think the strategy is? Well, we've got to multiply and then add. What's the order of operations say? Well, you guessed it. You're going to multiply first, and then you're going to add second. But you're only going to be able to add if they're like terms. If they're not like terms, you're not going to be able to add them. All right, let's look at the first one. Now, what do you do with the 2 times 4? You multiply. But what do you do when you multiply with the exponents? Well, the exponents get added. So x5, x1, that's x6, y2, y3, that's y5. Now multiply these two. These two go together, these two go together. Well, do you know what the number in front there is? You can't see it. That's a 1, and 1 times 3 is 3. Now add the exponents on the x's. That's going to be x6. Add the exponent on the y's. That's y to the 5th. Can you add these? Are they like terms? Are they like terms? Yes, they are. So we can add them. 8 plus 3 is 11. But remember, when you add, what do you do to the exponents? What's below add? Nothing. You do nothing to the exponent. So that stays x6, y5. One more, number 36. It's just like number 35. You're going to multiply these two and these two. And then if they're like terms, you'll be able to add them together. 4 times 5 is 20. Add the exponents on the a's. That's a 3 and a 1. So that's a4. b4 and b2. Add the exponents is b to the 6 plus. Now, that's a 1 in front times a negative 2. 1 times negative 2 is negative 2. I could have just written a minus there instead of plus negative. It's the same thing. All right, add the 2 and the 2 together. That's a to the 4. And finally, b5 and b1, that's b6. Are they like terms? Yes. So you can add them together. 20 minus 2, that would be 18, a4, b6. Now, had they not been alike, you would have just left them separate. You wouldn't have been able to add them. But since they're like terms, you can add them together.